Okay guys, welcome back, and hopefully that went well for you and you filled in all your boxes, nothing disastrous has happened, and your values look like mine. If you have run into problems and your values do look different to mine, do post in the forum for me and I'll see what I can do to try and help understand what happened. For now we'll continue. So apart from this guy down here, which I will go into in a little bit, what you'll see is that the further back in evolutionary time we go, so we're looking at organisms that are less related to humans, is that they have less percentage identity with their cytochrome C sequence. So that holds true until we get to this guy down here. Now this guy is really interesting and I will go into him in a little bit detail in a little while. But one extra thing that we can do here, if you do want to visualize how long ago we actually diverged, there's a wonderful website called Time Tree, and you don't have to do this. This isn't essential for the rest of the practical, but it is really interesting. So I'm just going to introduce you to Time Tree. And Time Tree is a great website. If you type in two taxa, or two species as it were, it'll tell you how long ago they diverged. So if we type in human, and we type in chimpanzee, and we just want to have a look how long ago they diverged, that was 6.6 million years ago. So if I just type in here 6.6 million years ago, and then if I do that with mouse, what I'm expecting is that should be even longer. So it is 90.9 million years ago. Now I'm sorry, I should have explained this in a little bit more detail. So here we have papers which are describing molecular time estimates. You don't need to worry about those. And here we have some geological periods just to show you. You can open them and close them up if you want to look into more detail. The value that I'm interested in is this one here. We don't need to worry about these two down here. So this is the only value I just want to look at for the purpose of this practical. So 90.9. 90.9 million years ago. And if we have a look at duck, bill, platypus, and such, and that's 179.2. And then if we have a look at Gallus gallus, which is a bird, Gallus gallus, and that was 320.5. I'm going to go ahead and copy these because I'm not very good with spelling out scientific names. 482.9. 482.9. And then this one. And that's 411.9. Okay. So the only reason I included that in there is just if that made it easier for you to visualize as we go further back in evolutionary history, as we go further back in time as it were, that they have less percentage identity. Now obviously until we get to this guy. And I will just skip to this paragraph here just to explain. So all of the above species are vertebrates. So this guy here is a West Indian ocean coelacanth, and he belongs to a very old order of fish. They're the oldest lineage of lobefin fishes, and all tetrapods, and that includes us, descended from this lineage some 395 million years ago. So the fact that it's present in this, and this is a very ancient species, very old, it tells me that this protein is very old, functional, and very vital for survival. So you can see that the above protein is present and it's similar and always remains above 80%. And that's basically saying that all of these species here have an 80% identical protein called cytochrome C that is identical to our own. So by looking further back in evolutionary history, by looking at organisms that we are less related to, this can help us understand the evolution of the protein. So we know that a very ancient species has this protein, which is our West Indian ocean coelacanth, and it means that it was around before the split between lobefin fishes and tetrapods. So what that means is before the lobefin fishes and tetrapods split off in terms of their lineages, many millions of years ago, this protein was present. But I want to know when. So if it was present that far back in evolutionary history, how far back is it still present? So now we're going to look at organisms that we are far less related to, and that is Candida albicans, which is a yeast, and Arabidopsis thaliana, which is a plant. So we're going to literally repeat everything that we've already done. So we can go back here, and I've already got it up. And there we go, Candida albicans, taxid 5476, 5476. Don't forget to make sure that it matches, and then whilst that's doing that, you can type in Candida albicans and human into here and see what it pops up with. So it's telling me that it was 1,302.5 million years ago. Very long ago. 1,302.5. 0.5. And this one is telling me that we have, if we can just scroll down here, so that will take us automatically here. So that one has a 66% identity. And then if we repeat that for Arabidopsis thaliana, and then again for this one. So that's telling me that it was 1,513.9. Oh, yep. If this ever happens to you when you're doing, if you're using Blast, guys, don't worry about it. It is the nature of Blast. Just go all the way back until it says that. Edit and resubmit. There we go. And just put it back in. It's okay. That's the nature of kind of online bioinformatics programs, as it were. Okay, so cytochrome. So if we click on the top one, so it's saying that it is 66% identical. So that's pretty much the same as yeast. Okay, so again, as we're going further back in time, which we can see here, we are getting a less and less percentage, and that's because we are going with organisms that we are less locally related to. So both Arabidopsis and Candida albicans are eukaryotes, so we can see that the protein is still present in eukaryotes because there are 3 domains of life. The 3 domains are eukaryotes, so eukaryota, archaea and bacteria. Those are literally, all life fits into those 3 domains. So now we have searched one of them, we have searched eukaryota, and we know that it's present in all 3. So we can see that the protein is present in all of them, although it's really important that I tell you we haven't sampled them all. So let's try further back in time. So I've already mentioned there are 3 domains in life, and let's do a general search. Let's just search the 2 other domains. So let's blast our protein against the 2 domains below, such as bacteria and archaea. So if we go back here, taxid 2, and search, so it's asking if you mean that. That's quite a huge divergence. And that's 4,290. 4,290. And how is our blast doing? It's taking a little while. Again, if this takes a while, guys, I will cut out a section of the video so it'll appear almost like mine happened instantly, but it didn't. I can imagine this is going to take a few minutes because it's searching against an entire domain, which is really rather huge.